Hey guys, welcome to the first video of Unit 3. This is Lesson 1, Part 1, or Part A. It's about complex number operations. Okay, so complex numbers are in the form of A plus BI, where A and B are real numbers. So real numbers is everything that we've worked with up until this point in your years of math. So like fractions, integers, whole numbers, decimals, rational, irrational numbers, those are all considered real numbers. BI is what we call imaginary part. I represents an imaginary number. So if you look down here, or an imaginary unit, I is equal to the square root of -1. We've never been able to take the square root of negative numbers, and if you try to do it in your calculator, it's going to give you an error. But that's because the square root of something is a number times itself would give you that number, but there's no number that we could multiply times itself to give us -1, and that is why we consider it an imaginary number. So for this one, we know what the square root of 16 is, but we don't know what the square root of -1 is. So that's why we use I to represent it. The square root of 16 is 4, and the square root of -1 is I. So what comes out is 4I. Same idea here for the square root of -3. That's the same as the square root of 3 times the square root of -1. Typically, we would just leave the square root of 3 as is because it's not a perfect square. So, but this -1 comes out as I, and then square root of 3 on the side, just like that. I'll box these in as we go. Now the bottom part, that we could break up as the square root of 20 times the square root of -1. 20 we can break down to 4 and 5, and 4 breaks down to 2 and 2, which would come out because that's a pair. And then this would become an I. So we pull out 2I for the square root of -1, and then this 5 right here has to stay inside. Okay, so it's basically like our typical work with radicals. We're just adding in the fact that we have to include an I somewhere because it's a negative number we're taking the square root of. Next part, example 1. Identify the real part and the imaginary part. Okay, so I'm just going to look at these two problems here. So the real is going to be 2 and -5, because 2 and -5 are real numbers. They don't have i's attached to them. And then the imaginary part is going to be anything that has an I next to it. So 4I and 2I. Now over here, if we look at just 1/2, there's no I anywhere, so that's considered real. But this 6I is all by itself, that is imaginary. All right, now we're actually going to solve for x with some of these. So for this first one, example 2, x squared equals -64. Typically, if this was just x squared equals +64, we would take the square root of both sides, and that's what we're going to do for this. And we would get x equals, the tricky part about this is, since we're taking the square root, there's actually a positive and negative answer. So we get plus or minus, and then the square root of -64, well, if I were to break that up, 64 is a perfect square. 8 times 8 gives you 64, but since it's negative, we got to include that I piece. So we get x equals plus or minus 8I. Then on the other side here with this one, our goal is to isolate the x squared. So I'm going to subtract 26 from both sides. You get 2x squared equals -36. Divide by 2. I'm going to write it up here. X squared equals -18. And just like with that last one, we got to take the square root of both sides. We get x equals plus or minus, because we're taking the square root, so that's where the plus or minus situation comes in. We'll probably talk about that in more details in class. The square root of -18, if I think of that as the square root of 18 times the square root of -1, 18 breaks up into 9 and 2, and then 9 breaks up to 3 and 3. So we would get 3 on the outside. Remember, the square root of negative 1 is I, and then what's left in the inside is this 2 right here. So our final answer becomes x equals plus or minus 3i square root of 2. That's kind of a nasty looking answer, but we're going to practice this a lot, so it will get better with time. Now I'm just going to erase this so it doesn't impede my work down below. Example 3 is write the expression as a complex number in standard form. Basically all this is you treat a number attached with I like it's a variable because we can combine like terms. So here we would add -1 and +3, which would give us 2, and then add 2i and 3i, which gives us 5i. Now make sure when you're writing these, the I portion of it comes last. So that standard form is to have 2 in front, which is the real number, plus 5i, which is the imaginary part, coming second. Now, when it gets tricky is when we subtract, because when you subtract, you have to distribute the negative. Nothing changes on this set right here. That still stays as 2 minus 3i. But when I distribute the negative, it becomes -3 plus 7i, because remember, 2 negatives makes a positive. So then we combine like terms. So 2 minus 3 gives us -1, and then -3i plus 7i gives us plus 4i. Okay, there's the answer to part B. And now C, 2i minus 3 plus I plus 2 minus 3i. We have to be careful, look for those negatives, distribute that. Now the positive, that doesn't change anything, so those answers are going to stay the same. So 2i, now we have to distribute the negative, becomes -3 minus I, and then plus 2 minus 3i, and combine like terms here. So let's do the real parts first, which are -3 and +2. If we add those together, we get -1. Then we want to add 2i, -i, and -3i together. So 2i minus I is going to give us plus I. Then we still have this minus 3i behind that. So we get -1, and then when you add these two together, we get minus 2i. And there's our final answer, simplified form. On to the last part. Okay, so for example 4, this is where we are distributing -i. That's what's out front. Got to distribute it to both terms inside. So we get minus 3i, because treat it like a variable, and then minus I squared. Now this is very important. Whenever we have I squared, that actually becomes a real number. If we come back up here, notice that I squared equals -1. The reason is because if I were to take the square root of -1 and then square it, that undoes the square root and the square, resulting in just -1. So if we come back down here to what we had talked about, we end up getting -3i minus, and then I replace I squared equals -1, so I plug in -1 in place of that. These two become a plus sign, so it becomes +1. So we get -3i plus 1. Now that's not in standard form. We need to switch these terms around because standard form has the imaginary part coming last. So our final answer ends up being 1 minus 3i. Okay, let's do the same thing with part B. So distribute, we get 8i minus 2i squared. Remember that whenever you see I squared, that becomes -1. So what this equals then, 8i, and it's -2 times -1. So when you multiply those, we get +2. Basically, it just changes the sign of the number there. So 8i plus 2 is the same as 2 plus 8i. We got to make sure that the I part comes second. And on to the last one here. -3i times 6 is -18i. And then -3i times 5i is minus 15i squared. This is going to become -1. And -1 times 15, -15 is going to become positive 15. We switch our answers around and we get 15 minus 18i. I'm just switching the order of these to give me my final answer. Okay, so you have problems 1 and 2. This is a 2-part lesson, so you only have 2 student problems for this, but you'll have to submit both of these note sections separately.